Before you write a single line of game code, you've already made your most consequential design decision. Most solo developers make it without ever realizing they've made it at all. This is solo dev versus the engine. Here is the fact that structures everything else. A commercial engine is a full house. It hands you graphics, audio, input, and asset pipelines already built, so you can focus on game logic. A framework gives you a floor, not a house. You still build every room yourself. Neither choice is wrong. But each one sets a trajectory, and trajectories compound over years. The case for a custom engine rests on one claim: zero bloat. Commercial engines are Swiss Army knives, carrying millions of lines built for genres you'll never touch: 3D physics, skeletal animation, VR rigs, sitting there, consuming memory and attention, contributing nothing to your 2D tile game. A custom engine keeps only what's load-bearing. Every line does something. Nothing sits there by default. Specialization shows up hardest at the extremes. Construct 3 holds 5 to 10,000 sprites at a stable 60 frames per second on mid-range hardware. GameMaker, natively compiled, pushes past that, to 10 or 20,000. A custom Fukan engine, hand-tuned vertex buffers, a simple shader, clears 100,000. That's not a marginal gap. That's an order of magnitude, bought entirely by specialization. But that benchmark measures exactly one thing: raw rendering throughput. It says nothing about the months of development time behind it, the tooling gaps you'll hit along the way, or the cost of porting to console. Include those, and the equation tips hard in the other direction. The 2025 commercial landscape is shaped as much by licensing trust as by features. Unity holds 25.7% of the market, largely through mobile, backed by an asset store over 100,000 plugins deep. But Godot has become the indie darling since Unity's 2023 pricing controversy: MIT licensed, zero royalties, zero hidden costs, built for 2D from the ground up rather than adapted from a 3D core. To build an engine is to accept responsibility for the entire technical stack. A usable foundation requires, at minimum, a window and graphics context, frame timing for a locked 60 frames per second, an input system, a vector and matrix math library, and a renderer that can display a textured quad. None of this is the game. All of it must exist before the game can begin. Tooling is the hidden cost that compounds most severely. One documented solo developer moved through 4 stages: programmatic positioning requiring a full recompile per tweak, then raw JSON entry, then a standalone editor, and finally a live runtime dashboard. That's not one developer's inefficiency, it's the normal trajectory. The commercial engine user gets this tool chain on day one. The bespoke developer spends years building toward it. Noida's development began with prototypes of falling sands simulation, not a game concept. The resulting engine, internally called Falling Everything, treats every on-screen pixel as an independent elemental state, governed by a cellular automaton rule applied across hundreds of thousands of active pixels every frame. That scale of parallel simulation lies outside what any commercial engine exposes. The custom engine wasn't a preference. It was a prerequisite for the game to exist at all. Eric Barone didn't build an engine from scratch. He built on Microsoft's XNA framework, which handled the lowest level setup while leaving game logic entirely under his control, a code-first path between full commercial adoption and building everything by hand. In 2021, Stardew Valley migrated to monogame to unlock more than 4 GB of RAM, a ceiling the game's own modding community had run into. The migration wasn't a crisis. It was a planned upgrade, possible only because Barone owned his own codebase. Lucas Pope's approach reveals a third model: use a commercial engine for its high-level systems, then go deep on the rendering layer to build something the engine can't do out of the box. Standard 1-bit dithering causes visual strobing as a scene moves. Pope's custom shader anchors the dither pattern to world space geometry instead, so it moves with the scene rather than against it. Years of shader work, inside Unity, that sits between using an engine and building one. The moment a solo developer targets console, the technical debt of a custom engine comes due at full value. Before any console-specific code, there's a legal entity to register, DevKit hardware to buy for 3 platforms, NDA sign-off, and concept approval. Then the certification loop itself, 5 to 10 business days per review, and most first-time indie developers fail 2 or 3 times before passing. Strip away preference and the decision reduces to 5 questions. Does your mechanic need technology no commercial engine supports? Do you need to ship within 12 months? How much do you weight licensing sovereignty? Do you have 10 to 15 years of relevant engineering experience, the rough skill floor for a usable custom engine? And, honestly, are you a game designer, or a tool builder? Neither is wrong. But the industry is full of custom engines that never hosted a finished game, because the builder's creative energy ran out before the tools did. For most solo developers in 2025, a commercial engine is the realistic path to a finished game. Godot offers sovereignty, MIT licensed, 0 fees, without demanding you build your own foundation first. The custom engine still wins when the gameplay is the technology, when the mechanic can't exist inside a general-purpose runtime, or when owning a decade of your own code base is worth more than the years spent building it. Build a custom engine because you must, not because you want to see if you can. That's Solo Dev versus the Engine, for Z-Bonatic. Written by Seth Brown, with Humanitarians AI. Thanks for watching.